Good day, mates. My name is David, and I will be giving an overview of our work entitled Functional Object-Oriented Network, Construction and Expansion, which was done by the USF RPAL group. A major task in robotics is learning about how objects are typically manipulated. An approach to this follows what is known as the theory of affordances, as originally presented by J.J. Gibson. The focus here lies on manipulations as tied to objects and their states. In this paper, we build upon the Functional Object-Oriented Network, or FOON for short, which was originally proposed as a graph-based knowledge representation for manipulations. This network contains two types of nodes, object nodes and motion nodes, which are used for representing manipulations. In this network, we have knowledge based on cooking activities from knowledge obtained from YouTube videos. Object nodes and motion nodes form what we call functional units, which are the basic learning units of FOON. These units reflect a single action in cooking, and they describe the transition of an object state before and after a motion occurs. A robot can make use of FOON for manipulation tasks. Given a target goal, a robot can search for the series of steps needed to solve a manipulation problem. Since the knowledge contained in FOON can span multiple sources of information, we can obtain novel and flexible task sequences. Despite this flexibility, however, there are still some limitations with FOON, because we will be limited to the knowledge represented exactly in FOON. We will not be able to adapt to new objects or new environments. And in order to do so, we will need to get new knowledge from new videos, and getting this automatically is a difficult challenge. So, in this paper, we opt to create new knowledge in a new way with what we already know. The intuition behind this is if we know how to manipulate one object, then we can also manipulate other objects similar to it. We use two methods with this intuition: expansion and categorization. With expansion, we create a massive amount of functional units for every pair of similar objects, which is good for patching up holes of missing knowledge. This drastically increases the size of the network. With categorization, objects are labeled with abstract categories, and this compresses the network and reduces the number of functional units, also resulting in faster search times than with the other versions of FOON. In our work, we found that using a compressed network results in faster searches and more successfully acquired task trees, and the expanded networks becomes too large for real-time use. Please feel free to stop by our poster for any comments or queries concerning the methods or results. And thank you for listening, and enjoy your ICRA A team.